In a system, there are a couple different things that happen to different forces. If you have one person who's running this way, who collides with another person running this way, what usually happens in real life? The bigger person, most often, will continue moving, while the little person gets flung away or knocked over or trampled. There's a lot of different things that happen to that. And while that has to do with force, that mostly has to do with something called momentum, which is in next chapter and not in this chapter. So even though in this situation where there's a collision, what happens is that the situation, when they collide, if their forces are equal and opposite, that results in a net force of 0. And that net force of 0 means that the system is either at rest or moving with a constant velocity. Now, the fact that the system moves with a constant velocity would still appear that the larger person is moving faster or has more of an impact, because net force of 0 means constant velocity, but momentum, which is something different, has a direct relationship to mass. So something that's larger, that has the same velocity as something that's smaller, is going to have some larger momentum. And larger momentum usually translates visually as having more force or having more of something. So even though forces can be larger, or forces can be the same, or a person can be larger, the fact of the matter is equal forces, when they happen, result in a net force of 0, which means either velocity is constant or velocity is 0. Those are your two options. There's no other choice, because as the system is as a whole, there cannot be an acceleration for either object. You need to have no acceleration for the system altogether when this type of situation happens.